Now the smart plug is probably one of the first devices that you'll purchase for your smart home. They're a cheap and easy way to add some brains to items throughout your home. Most of the time, you're going to want to use them to automate things like lamps, holiday decorations, or even a stubborn appliance. And now with some of the outdoor products, you can even control landscape lights, outdoor speakers, and decorations. But today we're going to take these ubiquitous smart products to the next level with some clever automations in Home Assistant, and use a feature that's now commonly found on most new smart switches. So let's take a look. Hi everyone, it's Ryan with This Smart House. So on today's video, we're going to be taking a look at setting up some helpful automations using smart plugs. Now you can utilize any smart plug for this particular project as long as it has power consumption monitoring on it. Now in my smart home, I have a variety of smart plugs. That's the beauty of Home Assistant. You can pretty much integrate anything you want from any different brand. But today I'm going to show you the new mini plugs from SwitchBot. Now these come in two different versions, the HomeKit version and the standard version. Now the HomeKit version is SwitchBot's first foray into HomeKit compatible devices. So unlike SwitchBot's other products that are primarily controlled via Bluetooth, these are actually Wi-Fi controlled, which means that even if you're not using the SwitchBot universe, you can utilize these, whether the HomeKit version with a HomeKit compatible hub or the standard version via API. Now both these plugs are rated for 15 amps of current draw, meaning most lights and small appliances work just fine. They're also compatible with Alexa and Google Assistant. The standard version retails for about $12 each, while the HomeKit version goes for $15. And they come in multi-packs if you want to stock up. Now to add these into Home Assistant, you have a few different options. For the standard one, you can refer to my video on using the SwitchBot API to add things into Home Assistant. This will set these up as REST switches and sensors so that you can utilize both the control of the switch and data from the sensor like power consumption. Now, as a note, I'll be updating this video because they've recently come out with a new version of the API that will not allow you to control items using the old API version. So keep an eye out for that new video. If you don't want to go the API route and you use the HomeBridge project, then you can use the SwitchBot Cloud plugin for HomeBridge. That brings everything in from your SwitchBot account into HomeBridge, where then you can add it into Home Assistant. If you're using the HomeKit version, it's even easier because you can directly use these with Home Assistant as Home Assistant has HomeKit support. If you're looking at one of these products and you want to use it with Home Assistant, I'd say you probably should spring for the HomeKit version because this version is directly compatible with Home Assistant and is a little bit easier and gives you a little bit more flexibility. Of course, if you're interested in any of these products, you can find links in the description. Now, if you're watching this video the week it comes out, SwitchBot is actually running a promotion where you get 25% off of all their products, either via the Amazon link or their official web store, if you use their coupon code. So if you'd like to take advantage of these, you can find links and the coupon code in the description below. This sale runs between October 10th through the 17th. Now, if you happen to miss the sale, you can always purchase them using my discount code, where you will save an additional 5%. Plus, it helps the channel. As for the setup of these products, it couldn't be any easier. For the standard one, you just need to open up the SwitchBot app, press the plus button at the top, scroll down and find the SwitchBot Mini. Then you just put the plug in pairing mode by holding down the button on the side for 2 seconds, and then follow the instructions to add it to your Wi-Fi. The plug will show up as discoverable in Home Assistant, but I've had some issues with getting fast information back from the plug, it taking 1 or 2 minutes to update that the plug's been turned on manually. So I'd recommend going ahead and trying to set it up as a REST device first, because you can control how often you pull the device to get faster information if that's what you need. Now, to add the HomeKit version to Home Assistant, you either pair it with the Home app, or you can follow the same instructions as the standard version by adding it in the SwitchBot app. So once it's on the network, Home Assistant should find it and be able to add it in as a HomeKit device. So now that we can see the device in Home Assistant, if you're using the HomeKit version, you'll notice that there is no power monitoring data brought into Home Assistant. And that's because the HomeKit API does not support power monitoring on any device. Now, before the HomeKit folks start telling me about the Eve app, doing some research, I found that this is not a standard implementation, and as far as what I've seen, the Apple Home API does not support power consumption being transmitted. So that is a limitation that's on the Apple side. This is not a limitation that comes from any brand like Aqara or SwitchBot. This is actually a limitation on the Apple Home API. Now, if you remember from my Aqara video, so now I've ran into this limitation before with my Aqara automations video. It also is HomeKit compatible, but power consumption does not come through on any of their devices. But not to worry, we have a way around this with the SwitchBot API. Now, all of the automations that I'm going to talk about today involve being able to detect energy use from the plugs. So we're going to be doing this via the SwitchBot Web API, which is a very nice, open, and well-documented API that's super easy to set up. And unlike other companies, this API is documented by SwitchBot, so that means it's going to be supported from now on. So not to worry, if you're not a coder, I have all the example code in the blog post here below. As I noted before, we're currently going to be talking about the version 1 API. They've recently implemented a version 1.1 API that uses a whole new authentication scheme. So I'll be creating an updated video to show you how to control and read devices using the version 1.1 API. All right, so quickly let's look at how to add power monitoring for our SwitchBot devices into Home Assistant. Now, if you haven't already played around with the SwitchBot API, I have a video up here showing you how to use the SwitchBot API to add SwitchBot devices to Home Assistant. So in the blog post, I've got 2 sensors and 2 automations that you can just copy and paste and replace it with the information that you need for your setup. So the first one is the REST sensor. So this is going to take all the information from the API and pull it into Home Assistant so we can parse it out from there. Now, one quick note, for some reason the API endpoint for the power is actually called wait. Don't let that confuse you. So the first example here, the only thing that you need to replace is this device ID. And to find this device ID, all we have to do is open up the SwitchBot app, open up the particular device, scroll down to device information, and at the top we'll see BLE ID. This is the Bluetooth MAC address. This is your device ID. If you take away all of the colons, that device ID is the hexadecimal code that's in here. So we will take that information, we'll combine that with the API token that we can retrieve by quickly going into the SwitchBot app, clicking on Profile. At the very bottom where it has software information, tap on that 10 times. That's going to bring up developer options. Click on developer options and you'll see 2 different codes that come up in this screen. The one we want is the token at the top. Both of these codes are used in the new 1.1 version of the API, but for 1.0, we only need the top token. That is going to be our SwitchBot API token. So with that 2 bits of information, the device ID of the plug, and our API key, we can go ahead and get started with the code. So looking at our code here, this is going to be a REST platform. This will be inserted in your sensors.yaml document. So it's a REST platform. You can change the name to whatever you want. Then under resource, we have the resource URL where you need to insert your device ID in here. So we need to remove everything, including the square brackets, and insert your device ID here. Then you'll notice the scan interval is set to 600. That's because there's an API call limit of 10,000 API calls per day. If you have numerous devices, you can run this over really fast. So we have a clever automation that will allow us to only query this at a faster rate of 1 minute when it's turned on. We'll look at that here in a second. So then the last thing you're going to need to change is the authorization. Now this is your API key, which I would recommend storing in your secrets.yaml. So you can create a key called SwitchBot_API in your secrets.yaml and put that long token in there. Or if you're just testing this, remove the exclamation secret, SwitchBot.API, and paste that in there. Repeat this for each of the plugs that you want to add to Home Assistant. All right, so before we save our sensors.yaml file, we need to quickly go in and add a power sensor dedicated just for our power output. So to do that, we use the second example code, which is a template sensor. So it's just a platform template. We give it a name. So this is the name of the device that you're going to call it. This is the entity ID. So garage_charging_power. And then give it a name, garage charging power. And then for the value template, we just need to update the entity ID in here to match whatever you did in the step above. So in this case, it's sensor.garage_charging_station. If you look above, that's the name of the device, garage charging station. So just take the friendly name, remove the spaces, and put underscores in there, and then everything's lowercase. We're going to pull the weight attribute, which is actually the power attribute for it, and then we're going to convert it to a float. And the unit of measurement is watts. So once we put those both in our sensors.yaml, put that in our sensors.yaml, we can go ahead and save that, go to developer tools, check your configuration, of course. And then if you scroll down, you can just reload the REST entities. And also you're going to want to do that for the template entities as well. So those should now show up in your developer tools, which you can do that just by going to developer tools, states, and search for those 2 entity IDs. And then we're just going to search for garage charging. So there we go. We've got the garage charging plug sensor where it's pulling all that information in. And then we've got garage charging power. So both of those are created and appropriately showing information. And the next thing we're going to do is very quickly create an automation. Now again, with this automation, you can just take what I have in the blog post, copy and paste that into a new automation, and then adapt it for your own usage. But I'll show you quickly what this does. So for this simple automation, we just need a time pattern trigger that will trigger every minute. That's what this /1 means. Is it'll trigger every single minute. And then under actions, we're using the run in parallel action. So that way we can check 3 separate items. And if any of them are true, they will all continue on. So all we're doing here is a simple if statement. If the garage plug is on, then it's going to run this service, Home Assistant Core Integration Update Entity. And then we're targeting our garage charging plug for this one. Same thing with the kettle. So please note, these are the REST sensors, not the power sensors that we created. So these are the sensors that get their information from the REST API, not the template sensors that pull the power from our existing sensors. So that'll run every minute. And then if that particular plug is on, it will refresh the data from the API. So that way we can more efficiently use our API calls. Now, all the automations I'm going to show you today can be done inside of Home Assistant because that's the primary brain for my smart home. But you could probably adapt these for whatever platform you're using as long as you can pull in the power consumption data. So for our first automation, let's head out to the garage. Now, if you're like me, you have a lot of devices that need to be charged daily and weekly. That's why I set up this charging station out here in my garage to charge my drone batteries, flashlights, one wheel, and electric skateboard. Now, one of the big problems with some of these chargers is that they remain on even after fully charging the battery or device. That's a problem because of something called phantom load. This phantom load is the power cost of just having the power brick energized. That could just be a few watts, but it does add up over a long period of time. And some chargers are not smart enough to know that the battery is full, and it continues to try to incrementally charge it as it drops down by 1%, which is very, very bad for lithium-ion batteries. Now, my one wheel has an annoying feature where when it's fully charged, it keeps the one wheel on, which means the lights are on and it continues to communicate with the app on my phone. So it looks like the one wheel is actually on and active even though it's sitting on the charger. So what's the solution to this? Well, I ended up just creating a small set of plugs for all of my chargers and connecting them to a smart plug with power consumption monitoring. So I just have a simple system where when I plug in a battery or device, I go ahead and hit the switch on the side of the smart plug, turning it on. Then it tells Home Assistant how much power it's consuming. When that power drops below a certain threshold, then Home Assistant turns the smart switch off. Plus, I get a nice notification letting me know that the charging is complete. So this is a quick and easy way of saving your sanity and your power bill just by taking away some of those extra phantom loads. Let's hop into Home Assistant and see how to do this. All right, so for our garage charging station, I'm actually basing this on a blueprint that I found. That blueprint is by Christopher Wagner, and I have a link in the blog post for a direct import. So you just gotta click the little blue button, and it's gonna automatically import it into your Home Assistant. So we just created a new automation based off that. So under the electric power sensor, this is gonna be the template power sensor that we created earlier, because we just need to be able to see the wattage being currently consumed. So we find that in our list. So in my case, this one's called Sensor Garage Charging Power. Then we're gonna set the threshold. This threshold is what you want it to fall below in order to turn off the switch. So in my case, I have it set for 5 watts. So if it drops below 5 watts for a period of time, it's gonna go ahead and shut off the switch. Then we need to select which is our target smart plug. So whatever entity ID you gave your smart switch when you imported it into Home Assistant, that's what we're gonna put in here. So mine's called Garage Plug Bridge. And then finally, we wanna set a wait time. This is the delay in how long it takes for this action to be completed. So basically, if your device is going to dip below a certain wattage for a period of time and then come back up again, you want to make sure you set this threshold long enough. That way it doesn't turn off the switch. So that's super simple. We save that, and then it automatically turns off the switch. Now, if you want to do the notification, you can copy the notification automation from the blog post, but it is a very simple setup. So this automation gets triggered when the previous automation runs. And so to do that, we just trigger off of the state of our automation. So up here in the entity, we just find the automation that we just created. So in my case, it's called Automation Power Turn Off Garage. And then we're gonna change the attribute to last triggered. So what that does is every time our automatic power off is triggered, it's going to trigger this automation. And then simply we create a notification that sends me a notification using the built-in Home Assistant notification in the mobile app. Simple as that. All right, so let's move on to our next automation. This one might seem a little bit goofy, but if you've ever used one of these manual hot water kettles, started a pot of water, and then if you're scatterbrained like I am, walked off to do something else while you waited and forgot that it's heating, then you come back to cold water. So this automation, we're gonna be using a combination of the power detection in the smart plug and notifications from Home Assistant. So how this works is we're gonna go ahead and turn on our smart switch and then fire up our kettle. Now what's gonna happen is Home Assistant is going to detect that the plug is on and that our wattage has exceeded a certain threshold. So we've set it for something like 10 watts. That lets us know that the heating element has turned on in the kettle. Then when the kettle finishes and it turns off, we get a notification indicating that the hot water is done and to let you know to go back and make your tea. So the second part of this automation involves a tea timer. So I've got it set up where if I press the on-off button 4 times in a row, then that tells Home Assistant that I want to start a timer. So I get a notification indicating that I have a tea timer started, and then 4 minutes later, I get a second notification letting me know that my tea is done and it's time to remove the tea bag. Now let's jump into Home Assistant and see how to set this up. All right, for both of our kettle automations, we need to create 2 helpers. So we go down to Settings, Devices and Services, and then go to the Helpers tab. The first thing we need to create is a counter. So to say Create Helper, Counter. So we just give it a name. Mine's called Kettle Button Presses. You can set an icon, a minimum, maximum value if you want to. Whatever your initial value is, in this case is 0, and then our step size is 1. So every time that we hit increment, it's gonna step this by 1. So the second thing we need to create is a timer. So again, we go to Create Helper and click Timer. So I've called mine T timer, given it a nice T icon, and set the duration. We'll set this for whatever duration you want to set your T for. And if you need to, you can always dynamically set this in the automation later on, but I just have mine set for 4 minutes. Now note, all timers count down, they don't count up. So if you want to count up, you have to do something different. We'll see we have 4 automations set up for the Kettle timer. So the first one is our very simple notification. So to create this, it's simply just a numeric state. So the entity we're looking for is the template power sensor that we created earlier, and we want to set a threshold. So I've got mine set, if it's below 10 watts, that's when it triggers. So we just say below 10. Then in this case, all it's doing is sending me that notification, telling me the hot water is ready. So then basically, whenever the kettle gets turned on, it'll jump up above 10 watts, sit there while it's warming up, and then when it hits temperature and turns off, it'll drop back down to about 0 watts. So then it drops under that threshold, sending me the notification. Then for the button pressing routine, where we set the timer, it requires 3 automations. So the first one is another simple automation. So this is simply a trigger based on state. So when the kettle plug is changed between off and on or off, then this activates. Then I have a service call counter increment, which then when we select our kettle button presses entity ID, then it's going to increment that. So if it's at 0, go to 1, 1 to 2, vice versa. So then we go ahead and hit save. So this automation, just simply every time you press the button, it increments the counter by 1. But you may ask, well, what happens if you press it a bunch of times and then it stays on? So the next key to this one is resetting that counter back to 0 after a set amount of time, which is where our button kettle reset automation comes in. Now this is triggered the exact same way as the last automation. When we have a state change on the kettle plug, it's going to run this automation. Then it delays for 10 seconds, so you can set this to any increment you want, but basically after 10 seconds, I want it to clear the counter. Then it resets that counter to 0. Using the service call counter reset, and then we select our entity ID of that helper. Now the trick for this one is by clicking the 3 dots, we go to change mode, I have this set to restart. So if you're not familiar with these modes, single means it's going to execute it all the way through start to finish, which isn't a big deal unless you have a delay in there. When I set it to restart mode, what it's going to do is it's going to go ahead and start that 10-second counter, but if I press the button again, it resets the whole thing and starts that 10-second timer over again. This way I wait for 10 seconds after the last button press, then I can clear that counter. Now finally, to start our timer, all I have to do is create another numeric state trigger. And for that state trigger, we want to use our helper that we created, the counter, that I call kettle button presses, and when it's above 3. So what this means is if it's 3, it's not going to trigger, but when it hits 4, so if you do it 4 times in 10 seconds, it's going to trigger this automation. And what that's going to do is that's going to start the T timer. So we're just going to use a call service. That service is timer start, and then we select our T timer from the entity list here. Then I have a notification to let me know, hey, the T timer has started. Now for the last bit of automation for this one, we just have a notification letting us know when the timer runs out. So for this, we've created a trigger that's based on an event. So what event we're looking for is the timer.finished. So when that timer reaches 0, it's going to put an event in the event bus called timer.finished with the entity ID timer.ttimer. So again, the name of our timer. So when that timer reaches 0, that's when this automation will trigger. And that's just simply sending me a notification, letting me know the tea is ready. There's a lot of automations in there, but they're very, very simple. And again, you can copy paste all of the code directly from my blog post. Let's move on to the next automation. Now here in my office, I have a smart plug connected to both of my 32-inch 4K monitors. Now I did this by using one of the Power Liberator style AC splitters. So I take 2 plugs and plug them into a single smart plug. The main reason why I set this up is so I can shut off the monitors when I'm not using them by pressing a button on one of my smart switches. This is so when I'm rendering video, I can shut the monitors off and not have to worry about them coming on accidentally in the middle of the night, and I don't have to put the computer to sleep so it can continue rendering in the background. It's also kind of fun to be able to hit a button and have a sequence start running in the background here to turn the monitors on and have these WLED lights turn on automatically. And the second reason for this is so I can actually tell when I'm at the computer and working. So in 2, this way I can tell when I'm actually sitting in front of the computer and working. So what I've done here is when the monitor switch is turned on and it consumes enough wattage to indicate the monitors are actually on in use, then I can start a timer showing how much time I've actually spent sitting at my desk. This also kicks on other various automations around the office, including turning on a booster fan I have to cool my office. It turns on polling in Microsoft Teams to pull my status for my status light to let my family know when I'm busy or on a call. Plus, it turns on a lot of other things throughout the room. So combining this with the ESP Presence project that I did a few months back, then I'm able to actually tell when I'm inside of my office and working. It also starts a timer showing how much time I've been sitting while working on my desk. Let's see how to set this up. So for the office monitors, I have a simple automation that basically counts how much time I've been sitting in front of the computer when it's active. So to do that, we need to create 2 helpers. The first being a date time. So we go to create helper, date and or time, and I've called mine start sitting time. And this is going to be a date and time sensor. So you give it a name. I call mine start sitting time. Then we want to take the input of date and time, both. Then we need to create a second helper, and this one is going to be a number. So this is going to be called total sit time, and we want to give this something like a maximum value of 1,000. Step size is 1, and the unit of measure is minutes. Create. Make sure to select input field and not slider for the display mode. So with those two created, let's hop over to automations. So the first automation is going to start the timer when the office monitors are on and above a certain threshold. So we just create a simple numeric state trigger. Now we're going to select the power sensor we created earlier, which is our template sensor. We want this to trigger when the wattage goes above 50. So when my monitors are in standby, they consume about 9.5 watts. When they're on and actively displaying something, they consume about 75 watts. So I set this threshold at 50, so we give plenty of headroom. Then all that's going to do is it's going to call the service input date time, set date time. And since we're using a template here, we're using the YAML editor. So you can just copy and paste this if you want to. So the date time is going to be now with 2 parentheses with nothing in between. That indicates that's the time when this is triggered. So it's going to put the time and date when this is triggered into the input date time. Then we need to select the name of our entity ID down here. So in my case, it's called sitting time. So what happens here is when the monitors go above 50, it's going to basically log the time when that happens. So for the second one, all we're doing is checking to see when the monitor switch power is below 50 watts, or we see if the monitor switch has been changed to off. Either one of these would indicate that I'm no longer sitting at the desk or I'm no longer working. So in that case, we want to do this bit of code here, which is going to call the service input number set value, and we're going to set it to this data template, which consists of our current sit time in minutes converted to float. Then we're going to subtract the current time, so this is the date time right now converted to a timestamp, and then we have the input date time sitting time. So when we first sat down at the desk, it's going to convert that to a timestamp, subtract those two, and then divide it by 60. So that yields the number of minutes between now and when we first sat down. And then it's going to add it to the total sit time for the day and then round it with no decimal points. It's going to update the input number, total sit time, to that new time. And then it's going to set the date time, sitting time, to right now. Then all you have to do is write a quick automation that clears this variable at the end of the day. I already had one created, so I just added in an additional component. At 2:30 in the morning, it's going to set the total sit time to 0. That's it. Now you can track exactly how much time you spend sitting in front of your computer. All right, there you go. 3 simple automations to make your smart home even smarter, all using a smart plug equipped with power consumption monitoring. Now, if you have a cool automation that you use in your house with smart plugs, feel free to leave them in the comments below. Also, if you run into any issues with the automations that I've shown here, feel free to leave a comment or join our Discord server. So I want to thank SwitchBot again for providing me the smart plugs for this video. If you're interested in picking any of these up, please use the links in our description. Your purchase helps the channel. Now, if you're new to the SwitchBot universe and want to see what you can do with their other products, then check out this playlist right here. I have videos showing you how to use some of their other products, such as the button pressing bots. I have a video on the new smart lock and one on how to integrate with Home Assistant. Look for an updated version of the Home Assistant integration video coming soon. And as always, please make sure to subscribe to our channel by clicking our logo right here. Thanks again, and I'll see you on the next video.